Welcome to another Theory of Computation tutorial. Today we'll be learning about non-deterministic finite automata. So let's get started. First thing, what are we going to learn today? Let's look at the topics. First we'll look at the revision of what is DFA, then what is the difference between NFA and DFA, and then example of NFA. Alright, so let's get started. First thing, what is DFA? So if you have not learned about DFA, I have made a video on that, detailed video. This is just a revision and definition. So if you want to learn about DFA, you can go and watch that video. Okay. So first thing, a deterministic finite automata consists of these 5 things. First thing, it is a finite number of states. We represent it using capital Q. Then we have a finite set of inputs. We represent it using sigma. Then a transition function. We represent it using del. Then we have a start state, and it is part of the finite number of states Q. So we represent it Q0, and a set of final states, and we represent it using capital F. Okay. So this was the definition of DFA. Now, what is the difference between a DFA and NFA? So basically, the DFA, what happens is based on the current state and the input. Okay, based on the current state and the input, we know what the next state will be. Okay, but in case of NFA, that is not guaranteed, because in NFA the next state is randomly chosen from multiple next states. Okay, so that is the first difference. Second difference is in DFA there is only one next state. Okay, but in NFA there can be multiple next states for each input. The DFA is simple to design. Okay, yeah. Because there is one input, for one input and one current state, there is only one next state. But in NFA, it is easier to design. It is actually more easier to design than DFA. But it is also easy to convert an NFA to DFA. Okay, so NFA to DFA, it is easy to convert compared to DFA to NFA. Okay, so these are the basic difference between NFA and DFA. Now what we'll do is, we'll look at the definition of NFA, formal definition of NFA. Okay. So the definition of NFA goes like this. It is also represented like a DFA, that is, it has Q, sigma, del, Q0, F. Now you might be thinking, then what is the difference between NFA and DFA? Well, the difference lies between the transition function del. So how the transition function of del works? It basically tells you the current state, the input, and the next state, and there is only one next state for each input and the current state. But whereas NFA, we have seen that there can be multiple next states. So that is the difference between the NFA and DFA, that the transition function is different. Now we'll solve an example so that you understand what is the difference. So let's say we have to construct an NFA over the alphabet 0, 1 such that we accept all the strings that end with 0, 1. Okay. So we are given the alphabet over here. It is 0, 1. So all strings of 0, 1 ending with 0, 1. So let's say this is our starting state. Let's call a starting state A. Okay. Now you get any input over here, 0, 1. We are okay with it. Then we should go to state B when you get an input of 0. And when you get an input of 1, you go to state C. And we call this state C final state. Okay. So this is the simple NFA. So it is very easy to design. NFA is very easy to design, and it is also easy to convert an NFA to DFA. We'll look at it into the next tutorial. Okay. So this is the NFA for it. Now you might be thinking, if you get an input 0, you go to state B. You get an input 0, you stay in state A. What is it? So this is the NFA's difference between NFA and DFA. That you can have multiple next states for the same input. That is, the input is 0. But there can be multiple next state, that is, it can be A or it can be B. Okay. Another difference is you can leave this NFA incomplete. Okay. You don't have to create trap states like DFA. Okay. So that is the next difference, that you can leave the NFA incomplete and it is still going to be a valid NFA. Now, what is the transition function for this? Okay. So we had said that NFA has 5 things. Correct? Just like DFA. So we'll write down those 5 things. So first thing was, it was a set of states, a set of finite states. What are the finite states over here? And we represent it using capital Q. What are the states over here? We have got A, and we have got B, and we have got C. Correct? Then what was the next thing? It was set of inputs, that is alphabets, and we represent it using sigma. And what are the inputs over here? 0, 1. What was the next thing? It was our transition function. We'll draw a transition function over here afterwards. but we'll look at our starting state. Starting state, and we represent it using Q0. Okay, so what is our starting state? It is A. Correct. Now what was the next state? It was final state. Final state, and we represent it using F, capital F. And what is the final state over here? C. Okay, so now we have got these four things, and we are going to look at the transition function del. Transition function, and we represent it using del. Now let's draw the transition table over here for this transition function. Okay, so yeah, so let's say this is a transition table, and we have got our input 0 and 1, and what are the states over here? A, B, C. Okay, so A, B, and C. Now you need to understand one simple thing over here, that in the NFA transition function, you just don't write the states, you write it as a set of states. Okay, so if you are in state A, okay, if you are in state A and you get an input of 0, which state you are going to go? You're going to go either into A or you're going to go into B. Okay, so let's write it as a set of states, so A comma B. It can be either of these two states. What about if you get an input of 1? If you get an input of 1, you're going to stay in state A. So let's write it as set of single state A. What about B? You get an input of 0. Where you're going to go? It is not mentioned, right? It's okay, it's incomplete. So if it is not mentioned, you write it as empty set. Okay, so let's write it as empty set or null set. And if you get an input of 1, you go to state C. So if you get an input of 1, you go to state C. Fine. What about C? If you get an input of 0, where you are going to go? It's not mentioned, so write it as null, that is empty set. And if you get an input of 1, it is still not mentioned, so write it as null. Now understand this one thing exists in NFA, that is a null set. It can be empty. Okay, so this is the transition function for an NFA. Whereas in DFA you had seen there were only one next states mentioned. There was no null. It was either going to go into a trap state, but you don't have to create a trap state in NFA. So this is the difference between an NFA and DFA, and we have looked at an example of NFA now. So I hope you got the basic concept of NFA over here cleared. If you have any queries, feel free to ask me in the comment section below. Thank you.
So that's it for today, guys. Thank you very much for watching. If you have any queries, feel free to ask them in the comment section below. If you have any suggestions, please write them in the comment section below. If you like the video, please share it with your friends and subscribe to my channel. Thank you very much.